Hey everyone, today we're going to continue talking about entropy. So what is entropy? I always like to think of this example. You clean up your room, organize it. A week later, it's looking pretty messy again. So here's a little comic. The kid says, I blame entropy. So what is entropy exactly? A measure of randomness or disorder in a system. Okay, I like to think of messiness. Okay, which one is messier? Entropy can also be viewed as energy dispersal, as you saw in the ed puzzle yesterday. More entropy means that more energy is being spread out. So what do you think? Do systems tend to go towards order, or things tend to go towards disorder? Do things tend to get more messy? So, if you said disorder, you'd be correct. Okay, the second law of thermodynamics states that the entropy of a system and the surroundings are always increasing. Okay, so what that means is things tend to move towards disorder. Okay, so what is entropy exactly? Well, entropy, which we'll use the letter S for, tells us if the reaction is likely to occur. And so if things move towards more disorder, if there's an increase in entropy, then reactions are more likely to occur. If there's a decrease in entropy, right, less chaos, then reactions are less likely to occur. Okay, so that's what delta S tells us, just like how delta H told us exo or endo, right, positive or minus. So this is what delta S or entropy tells us. Okay, in Kool-Aid, we can make it more disorderly by mixing it up, right? If we spread out the energy, if we dissolve all the Kool-Aid, that'll increase entropy. Other examples of entropy conceptually, you can think about different phases of matter. If you've got an ice cube and you move towards a liquid, right? Liquid has more chaos, more disorder. So you're going to increase in entropy as you go from solid to liquid to gas. So on the left side here, we have high entropy. On the right side, lower entropy. Okay, so gases, because they're constantly bouncing around here, right, they have the highest entropy. They're moving around a lot of chaos, a lot of randomness, right, which is how we're defining entropy here. Okay, so gases will always have the highest entropy of all phases. Okay, we can also think about salt. When salt dissolves, should be a plus, or actually, this is our reaction. Here, the formation of salt, we've got solid and a gas becoming a solid. So when a gas becomes a solid, there's a decrease in entropy because it's becoming more orderly. A crystal salt is very orderly. However, if we dissolve solid salt into water, we get an increase in entropy. Okay, and that's because we're forming two ions here. There's also more chemicals on this side. We have two chemicals versus one. So think about, if you had a pet or if you had some children around the house, what's going to be messier, if you have two kids or if you had one, right? So lastly, I'm going to show you how to calculate the delta S of a reaction and what does that exactly mean. So this is just like the delta H kind of problem we did before, except we're using different numbers here. Same idea. We're taking total products minus total reactants. So delta S is going to be my total products. So I've got 2HI, I've got chlorine, minus my total reactants. I've got I2, and I've got 2 HCl's. Okay, once I've set it up this way, I can now plug in the numbers, and that's exactly what I'll do. Don't forget, if you have multiple, then you want to use coefficients. So I've got 2 HI's here, so I'm going to use 2 of them. I'm looking at the table to the right. And just be careful with the math. Make sure you're not mixing them up. All right, I'm going to simplify these numbers. So on the left side, we've got 635 minus 491 that gives me 144, and the units are joules per Kelvin mole. Okay, so what does a positive value for entropy tell me? Well, that means that there's an increase in entropy. Things are getting more disorderly. So is this likely to happen? Well, if there's an increase in entropy, then yes, this is likely to happen, okay? Because systems tend to move towards more disorder or higher entropy. All right, try the practice problem that you have on your own. Follow this example and